Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand the importance of data screening in structural equation modeling. Data screening in structural equation modeling refers to the process of assessing the quality and suitability of the data before conducting the structural equation modeling analysis. It involves various procedures aimed at identifying and addressing issues such as missing data, outliers, non-normality, and other data-related problems. The purpose of data screening is to ensure the validity and reliability of the data used in SAM analysis. Let's say we are having this data. The quality of the data when we are assessing column-wise, this is done with the help of reliability and validity testing. When we are assessing the quality of the data, considering two indicators of the same construct, say for example, OC1 and OC2 are the indicators of the organizational commitment. This we are doing with the help of reliability and the validity testing. The measures of reliability and the convergent validity which will be used are Cronbach alpha, composite reliability, and average variance extracted. To assess the quality of the data, for the indicators of the different construct, we check the divergent validity of the construct. The measures of divergent validity are Fornell-Larkin criterion, heterotret-monotret ratio, variance inflation factor. When we are assessing the quality of the data row-wise, this we are doing with the help of SPSS or Excel, and we will be calculating the standard deviation and average. Let's take one example. We are having this raw data file. Now see the opinion given by the respondent 1. 5, 5, 5, 5. Let me try to explain this, that what it is known as. Let me scroll this first. The first respondent is giving the opinion all 5. So this respondent is known as unengaged respondent. With respect to Likert scale, there are times, especially in lengthy self-reported questionnaires, when respondents provide linear answers. That is, they give constantly the same rating to all questions, regardless if these questions are reversed or not. Any respondent having mean value less than 0.5 or more than 4.5, if we are using 5-point Likert scale, should be deleted. Any respondent having standard value less than 0.25 means that there is no variation in giving responses. In other words, respondent has ticked all 1s or 5s. So we will have to delete these rows where standard deviation is less than 0.25. Let's go back to the raw data file. First, we will calculate the average of these responses. This we can do with the help of the formula average B2 to U2. Make sure you only consider the the statements which are on Likert scale. You will not include the serial number. ID will not be included. So if this number is less than 0.5 or more than 4.5, if we are using 5-point Likert scale, then this should be deleted. In this data, there are EP1 and EP2 which have been captured on 10-point scale. But for your understanding, if all the statements have been captured on 5-point Likert scale, then the row which is having the value, average value less than 0.5 or more than 4.5 should be deleted. Similarly, if all the statements have been captured on 10-point scale and any observation is having the value less than 0.5 or more than 9.5 should be deleted. Then we will compute the standard deviation. Standard deviation will be computed with the help of the formula standard deviation dot P, B2 to U2, all Likert statements. If this value is less than 0.25, we will delete it. It means that there is no variation in the responses, or in other words, this particular respondent has not read the questionnaire. he or she is doing the extreme ticks either on 1 or 5. It may be quite likely possible that there may be many such responses and we will have to identify so that we can delete it. This we can do with the help of sorting. But first we want to generate the standard deviation of all of them. What you will do after entering the formula, double click here and the formula will be replicated in all other rows. Now click here and go to the data. Do the sorting A to Z. Sort. So there are two observations. Observation number 16 and observation 1. You can see more or less their responses are linear. They have not read the questionnaire. It is not necessary that it will be 5, 5, 5. It can be 1, 1, 1, 2, 2, 2. Basically, the linearity is maintained. And therefore, we will have to delete this. The next thing which we have to assess in the data is outlier detection. Outliers are extreme unusual observations that can have a disproportionate impact on the analysis. Data screening involves identifying and assessing the presence of outliers in the variables included in the SAM model. Outliers can be detected using the graphical methods or statistical methods. Graphical methods are box plots, scatter plots, or statistical methods are z-scores, Mahalanobis distance. Depending on the nature and cause of the outliers, they can be managed through techniques such as vinsorization, trimming, or exclusion. Let's see how we can do this in the data file. I go in the SPSS file and analyze descriptive statistics and descriptives. I'll transfer JS1, job satisfaction, the first statement of job satisfaction, JS1. Then I'll pick up the second statement of job satisfaction, JS2. So basically there are 4 indicators of job satisfaction, JS1, JS2, JS3, and here it is given the name US4, but it is JS4 only. These indicators have been captured on 5-point Likert scale. That is, the minimum is 1 and maximum is 5. Any other response that is above 5 or below 1 should be deleted. So click OK and let's try to find out, are we having any such response? So maximum is 7 here. JS2 here also 7, here 6 and 5. So there are some statements, or rather there are respondents who have entered more than 5. Therefore, we will have to delete this, or we will have to check this observations where the 7 number has been entered. Just understand this. Our questionnaire is on the Likert scale: strongly agree, agree, neutral, disagree, and strongly disagree. The minimum can be 1 and maximum can be 5. There is no possibility that there can be 6 or 7. So we will have to find out these observations and either we can rectify it, we can correct it, or we can delete it. So how we can find out these observations? So we will go in the raw data file and click here, press Ctrl F and find the observations where 7 has been entered. Find next. So it is a discretion of the researcher what to do. Either you can replace this with the correct observation, 5 or 4, whatever it is, or you can delete this observation. So this is outlier detection. The next thing which we have to check in the data is missing values. Data screening involves examining the extent and pattern of missing data in the variables included in the SAM model. Missing data can be addressed through various techniques such as imputation method, including mean substitution, regression imputation, or multiple imputation. The choice of missing data handling method depends on the nature and extent of missingness. Let's say we are having this data file where the missing observations are here 4, 7, and 12. First, we will have to identify where the missing observations are there. How we can do this? So we will go in the data set deliberately. I have introduced some missing values here deliberately. Okay. I'll go in analyze descriptive statistics and now run frequencies. Enter the statements. Let's say I'm entering 4 statements of organizational commitment: OC1, OC2, OC3, OC4. When you're working on your data set, this you will have to do for all the variables. Click OK. And now click OK. Let's see the result. So it indicates that there are 3 missing values in your data, that is OC2. So this you can go in the data file and you can locate it, that there are 3 missing observations. Now what to do with these missing observations? The remedial measures for handling the missing data. Either it can be deletion or imputation. Deletion can be deleting the rows list-wise deletion, or it can be the pairwise deletion, or it can be deleting the columns. Imputation, is it a time series problem or a general problem? In general problem also, we will have to decide, is your variable categorical or continuous? If it is a categorical variable, we will use the technique multiple imputations or logistic regression. If your data is continuous, like height, weight, this will be imputed with the help of mean, median, mode, multiple imputation, and linear regression. We will see this method, how to do the imputation. Deletion, list-wise deletion. It removes all the data for an observation that has 1 or more missing values. Particularly, if the missing data is limited to the small number of observations, you may just opt to eliminate those cases from the analysis. Make sure that you don't delete many observations. Pairwise deletion. Pairwise deletion analyzes all cases in which the variables of interest are present and thus maximizes all data available by an analysis basis. A strength to this technique is it increases the power in your analysis, but it has many disadvantages. I'll give you an example. There is one small data which I am presenting here. We are having the variable y, x1, x2. In y, this is the missing observation. In x1, this is the missing observation. And in x2, this is the missing observation. So in y, 5th number is a missing observation. In x1, 4th number is a missing observation. In x2, 1 number is a missing observation. So where any statistics is computed, say for example, covariance. Covariance between y and x1 is calculated on the basis of observation number 1, 2, and 3. This missing entries will not be taken for the consideration. Covariance between x1 and x2 is calculated on the basis of observation number 2, 3, and 5. This is known as a pairwise deletion. Dropping variables. Sometimes you can drop the variables if the data is missing for more than 60% observations, but only if that variable is insignificant. Then comes the data imputation. Data imputation is a technique used in data analysis and machine learning to fill in missing values in the dataset. Missing data can occur due to various reasons such as data entry errors, equipment malfunction, or participant non-response in surveys. Imputation is a process of estimating or predicting the missing values based on the information available in the dataset. The goal is to create a complete dataset that can be used for further analysis or modeling without disregarding the observations with missing values. 2 most commonly used data imputation techniques are mean median imputation. Missing values are replaced with the mean or median values of the corresponding feature. This method assumes that the missing values are missing completely at random. There is no pattern in it, and that the mean or median adequately represents the missing value. Then, another technique is regression imputation. A linear regression model is used to predict missing values based on the other variables in the dataset. The missing values are imputed using the predicted values from the regression model. Now you can see here we are having the missing data. One of the strategies is deletion. So, deleting this observation. but I will not recommend this strategy. Rather, you should go for data imputation. So for this, go in transform, replace the missing values. OC2 is having the missing values. So transfer this OC2 and this OC2 will be replaced by the mean. You can see here the replacement. The imputation is done by the series mean. Just press OK. So you can see it will generate the new variable OC2 underscore 1. Click OK. This is mean imputation. Now you can go on the fag end and you can see that the observations which were missing have been replaced. 8.4, 8.4. So these are replaced with the mean. This is the first method. It is imputation by mean. Let's see the second method. Again, go back, transform, replace the missing value. Now, again transfer OC2. And now I want the linear interpolation. That is, click here and press change. So now it is lint OC2. It will again generate the new variable OC2 underscore 2. Click OK. Click OK. And again go at the fag end. A new variable will be generated, OC2. So you can see here, the replacement has been done with the help of linear interpolation. The next thing which you have to check in the data is the multicollinearity. Data screening includes examining the presence of multicollinearity, which refers to high correlation among the predictor variables. Multicollinearity can affect the stability and the reliability of parameter estimates in structural equation modeling. Techniques such as correlation matrices, variance inflation factors, or condition indices can be used to assess the degree of multicollinearity and determine if any variables need to be excluded or combined. At present, when we are working on the raw data file, we'll be testing the multicollinearity with the help of correlation matrices. In the software, software generates variance inflation factors or condition indices. The threshold value to avoid multicollinearity in a correlation matrix can vary depending upon the specific context and analysis being performed. There is not a universally accepted threshold value that applies to all the situations. However, commonly used guideline is to consider a correlation coefficient greater than 0.7 or less than minus 0.7 as indicating a high degree of multicollinearity. When examining the multicollinearity, it is advisable to use a combination of techniques and consider the context of the analysis. In some cases, even lower correlation coefficients, example 0.6 or 0.5, may be considered significant depending on the field of the study and specific research question. The reference I have given here, that is Hare et al. Now let's see how we can detect the multicollinearity in Excel. Now we want to check the multicollinearity. So for this, we'll go in the data and we will activate the data analysis toolpack. I'll select all the variables from here. Make sure these are the statements which have been captured at the Likert scale. We will not include the average and standard deviation which we had computed previously. Now you go in data, activate the data analysis toolpack, and in this, activate the correlation. Click OK. You will have to do one tick that the labels are there in the first row. So OC1, OC2, OC3, the labels are there in the first row. Click on it. If you are not getting the input range, again, select it from here. Press Shift button and select till U2. Click OK. So you have got the correlation matrix. Now I want to see the correlation among the indicators of the same construct as well as a different construct. The desirable is that we should have a high correlation among the indicators of the same construct. For example, we want a high correlation between OC1, OC2, OC3, and OC4. So let's say this is desirable. So 1, 2, so this particular triangle is desirable, right? Now, what is not desirable is that the indicators of different construct are highly correlated. That is not desirable. For example, JS1, JS2, JS3, JS4, these are the indicators of the job satisfaction. EP1, EP2, EP3, EP4, these are the indicators of environmental perception. AC1, AC2, AC3, AC4 are the behavior of the co-workers. And SI2 to SI4 are the staying intentions of an employee. OC to OC4 is organizational commitment. The indicators of the different constructs should not be correlated with each other. For example, AC1, which is the indicator of the behavior of co-workers, should not be highly correlated with the job satisfaction, the indicators of the job satisfaction. So for this, we will have to do the conditional formatting to find out, is there any such relationship there or not? So again, I'll go in home. I'll activate the conditional formatting. Highlight the cell rules, greater than. So let's say 0.6. Now let's try to pick up OC4 and OC2. The correlation is 0.74, quite desirable because these are the indicators of the same construct, no issue. EP3 and EP2 and EP3 are strongly correlated, no issue, right? So here also, these are AC3 is strongly correlated with AC1, no problem. Let's now lower this and make it 0.5. Still, there is no problem. But if I make it 0.4, you will be able to understand what I'm trying to explain. Say this, SI1 is having a correlation of OC2. SI1 is having a correlation with OC2 and the correlation is 0.42. Now, as it is less than 0.5, there is no need to worry. But this way, you can detect that are the indicators of different constructs showing correlation or not. This is the problem of multicollinearity. If you are having such problem, the remedial measures can be either delete that statement or merge the two statements into the one. The remedial measures for multicollinearity is variable scaling and centering. Data screening may involve scaling and centering the variables included in the SAM model. Scaling refers to transforming the variables to have a specific mean and standard deviation, which can help in interpreting and comparing the parameter estimates. Centering refers to subtracting the mean of a variable from each observation, which can help in reducing the collinearity and improving the interpretability of the model. Next is data distribution assessment. SAM assumes that the data follows the multivariate normal distribution. Data screening involves examining the distributional properties of the variables included in the SAM model. This can be done through the graphical methods, which are histograms, QQ plots, or statistical tests such as Shapiro-Wilcoxon test and Kolmogorov-Smirnov test. If the data deviate from normality, appropriate transformations such as log transformation, square root transformation, or robust estimation methods like maximum likelihood estimation with robust standard errors can be used. So this was all about the data screening in structural equation modeling. For more videos on SPSS AMOS, kindly refer to my playlist where I have already uploaded many videos on SPSS AMOS. Please, you can also follow me on LinkedIn and Twitter. Please don't forget to subscribe the channel and press the like button.